the agent-to-agent protocol. And if you ever wondered do how do these different AI systems actually work together without you babysitting the whole thing, this is basically the answer. And by the end of this video, you'll be able to understand what A2A is, how it actually works under the hood, and most importantly, why it matters for you if you're building anything with AI today. Let's get started. So in the world before A2A, imagine you're building a customer service bot. It needs to understand what the user is asking, check your knowledge base, look up the account in your CRM, and log the conversation. So this is basically 4 jobs with 4 different AI tools, possibly from different companies. And the way they are connected, we had to write like a custom code for each single pair. So agent A talks to agent B, you write the code for that. Agent B talks to C, you write the code for that. And this was basically a mess. And each AI system lived in its own bubble. There was no universal way of one agent to even know the other one existed, let alone hand it a task. So we also had custom integrations. So every connection was kind of bespoke, and this meant that everything was brittle, and it could always break. Everything will always break, and if it breaks, you had to go dig deep into your code and try to find out where the problem is. The third problem, we didn't have any interoperability, because if an agent was built by another company, for example, OpenAI, and another agent was built by Anthropic, they couldn't just talk. There was no common language. You had to translate between them manually. And as a result of this, scalability really suffered, because building a multi-agent pipeline, like for example, building a 10-agent pipeline was 10 times harder to create than building one. So A2A comes as a fix for all of that. And let's use the HTTP analogy, because I believe it will make everything else click. So think about back then in the 90s, when in the early web, so where every website was its own island with different formats, different protocols, and basically no standard way for a browser to talk to a server. Then HTTP came along. So HTTP came along as one universal protocol, and suddenly any browser could talk to any server anywhere in the world. That's basically what unlocked the internet as we know it today. A2A does that for AI agents. It's an open standard built on HTTP and JSON, so it's very familiar. And this gives every agent a common language, a way to say, here's what I can do, here's how to give me a task, and here's how I'll send back the results to you. So it has 4 pieces. The first one is the agent card. So the agent card is like a business card that, think of it like as a business card that every agent publishes somewhere, which says my name is this agent, I can take this type of query, and I can return this type of result, and here's how you can authenticate with me, and here's whether I can support streaming. So second is the task lifecycle. So when you give an agent a job, it doesn't just fire and forget. It tracks that with a unique job ID, and it moves through the steps: submitted, working, then completed. And basically, you'll always know where things stand at that time. And then third is streaming. So for anything that takes like long, or something like a second or two, the agent can push progress updates back to you in real time using server-sent events. Basically, no timeouts, things like that. And fourth, it has multimodal support. So one task can carry different data types like text, file, structured data, or even a combination of all of them, not just limited to strings. So how does it actually work? Let's walk through like a real example. Imagine you're building a research assistant, right? And a user just asked a question: what are the biggest trends in renewable energy in 2026. The first step is discovery. The orchestrator agent, the agent that's managing the entire flow, needs to find a search agent. This search, it goes and fetches that search agent from where it was published, right? And the card says, I accept a text query, I return web results, and no authentication is needed. Yeah, so first step, it has fetched the agent card for the search agent. The second step is to delegate. So now this orchestrator agent sends the task, like a simple HTTP post request to the search agent, which maybe provides an endpoint or something like that, with a unique task ID that the user, with a unique task ID that will be used to track, and then also with the user's question in the payload. So in the third step is execution. So this search agent goes over and does its thing, does the search, do everything it does, and then returns the result. And then in the fourth step, the search agent returns the results, like in a structured way, not just like a text. And then in the last step, the fifth step, this orchestrator agent aggregates that result from the search agent, maybe combines them with what maybe you had, like a summarization agent that summarizes everything, what a summarization agent found, and then assembles everything into one clean answer. So why does this matter? Why does this matter beyond just being like a tidy protocol or a cleanup tool or something like that? So it's vendor neutral. It's an open standard backed by Google, Microsoft, and others, but it's not owned by any one company. Yes, it was created by Google, yes, but it's now managed by the Linux Foundation, so it's open source. And this means that your search agent can be from one provider, then your summarization agent can be from another provider, and your CRM agent can be from another provider, and they all speak the same language. You're basically not locked into a specific company's ecosystem. Two, it's scalable by design. So if you want to add a translation agent to your pipeline, you don't touch any of the other agents. You just plug it right in, and none of the other agents will even know that you've added a new agent. Security is built in, so authentication is not an afterthought. It's basically one of the specifications in the agent card that's being fetched. So you'll know that everything is secure even before you send it a task. And then four, we have real-time streaming. So these long-running tasks don't basically freeze your system. Gives you like feedback, like something is hanging or something like that. So the agent keeps the connection alive and pushes updates. So you won't have to wonder if something is finished or not, because you'll always be updated. And five, and so for five, it's basically what I'm most excited about. You can mix and match agents like Legos. A search agent plus a summarization agent plus a citation agent in a research pipeline. Swap out the search agent for a database agent, and you've got something very different. And it basically changes your entire flow in minutes, not in like weeks. And then last one, it's observable. So since every task has an ID, every state transition is logged, and if something goes wrong, you can basically trace exactly where which agent dropped or which agent failed and at what point it did fail. And this is a very huge plus. This is a very huge plus for production environments where trust and reliability matters. So so three pipelines you can actually build with A2A today. One can do something like a customer support agent, a customer support implementation where a user messages your bot with something like my order hasn't arrived or I need a refund. And then the agent reads that and classifies it like as a refund request, and gives it an urgency of high, and then it hands off that to like another agent which detects frustration from the user and flags it for faster response. And then we have a knowledge base agent that pulls the refund policy according to your company's refund policy, and then a CRM agent looks up the order and patches it into the customer's account status, and then all of this happens in within seconds, and then the user gets a response that feels personal and without having all those four agents knowing about each other, because they all communicated through the agent-to-agent communication, agent-to-agent protocol. And then another pipeline you can build, the one that I talked about earlier, a research assistant. A user's task asks maybe asks to asks a question like, give me a briefing on the top AI papers published this week. So we have a planner agent which breaks that down into different queries, and then a search agent runs all these queries against maybe a database where all these research papers are being published. And then we have a summarization agent which distills each paper to 3 sentences, and then a citation agent which basically formats the references, and then the user gets a clean briefing which is structured, sourced, and ready to share in the time it used to take to just open a browser tab. So and the last pipeline I think would work is maybe in software development. So imagine a developer pushes code into a branch, and then a code agent reviews it and suggests improvements. A test agent runs the test suite and reports the coverage. And then a review agent checks for security issues. A deploy agent ships if everything passes. And then the whole review to deploy cycle happens while the developer makes tea or a coffee, and that's basically what A2A does. So to leave you guys, the next phase of AI, I don't think is about building incredibly smart models that do everything. I think it's about networks of specialized agents, each excellent at one thing, and all of this they collaborate to do something remarkable together, and that only works if they can communicate, and that's what this protocol A2A gives us: a universal language and open standard, not owned by anyone, available to everyone. And yeah, so I think